So in this lecture, so far we've seen about vector calculus. So we've seen about different coordinate systems and how to move between different coordinate systems, curvilinear coordinate systems. So here we're going to take an example problem. So we've seen about vector calculus, the theory we've seen, differential calculus and integral calculus, well, vector calculus. So now we're going to look at some problems. So we're going to solve some problems and get a feel for the subject. So here we are given that this is the question. So the question is such that if so x is given, okay, so we are given the relationship between x is equal to given as u v cos w and y is given as u v sin w and z is given as half u square minus v square. So that's z. So z is given as half u square minus v square. Now our new coordinate system is given by u, v and w. So u, v, w are the new coordinate system, the variables in the new coordinate system. And now these are the relationship between x, y, z, the old coordinate system, and the new coordinate system u, v, w. Now we are asked to derive, we are asked to find out. Now we know the line element is in this old coordinate system. We know it is dx square plus dy square plus dz square. So this is the line element in the old coordinate system. Now we're asked to find out the line element in the new coordinate system. Of course, it is du square plus dv square plus dw square. But as I said, as we had seen in the theory, now the line element is now changed, scaled, rescaled by some parameter. So it's either expanded or squished. Okay, so it's h1, the scaling factor is h1, h2 for v and h3 for w. So we are asked to find out what these scaling factors are. This is the required problem. So this is what we are supposed to find out. So how would we proceed to do that? Okay, so first step in this problem is to find out dx. So dx from this equation. So dx from this equation. So from this equation we are supposed to find out dx. So dx we will write it in the, so the differential dx is nothing but the chain rule in partial differentiation is dou x by dou u multiplied by dou u plus dou y, dou x by dou v multiplied by d plus dou x by dou w multiplied by dou. So this is what we are supposed to do. So the differentiation of this quantity partially with respect to u is nothing but u cos w and multiplied by du, and the differentiation of this quantity x again partially with respect to v is nothing but v cos w multiplied by dv, and the differentiation of this quantity now, the differentiation of this quantity partially with respect to, the differentiation of this quantity again partially with respect to w. So the differentiation with partially with respect to w now. So that is nothing but minus uv sin w. So likewise we similarly find out dx. So we found out dx. Let's now find out dy. So dy is the chain rule of partial differentiation. So the chain rule of partial differentiation, just writing it out, and then we'll find out the differentiation. So this is, so now it's the second function y. So y, so this function you now partially differentiate with respect to u. That is nothing but you have u sin w du plus v sin w dv. So, and then again this quantity partially differentiated with respect to w. Now it's partially differentiated with respect to w. So this was partially differentiated with respect to v, now w. So that will be uv cos wd. So that's it. So now we have to find out dz. So dz, now we'll write out the z function so that we know we have the z function here, so that we are not so that we're not lost. So we have to, so we write out the z function so that we're not lost. So u square minus v square. So now the differential dz is nothing but we use the partial differentiation chain rule. So I'm presuming you know partial differentiation. So uh, since this is at a more higher level mathematics uh, course, so lecture series, we just presuming that you are aware of the rules employed in partial differentiation. So partial differentiation means that when you're differentiating this quantity with respect to u, you only treat u as a variable and treat everything else as a constant. So supposing v, you treat v as a constant here when you're differentiating partially with respect to u. So when you're doing that, so what will happen? So the first quantity, there is a half outside, and when you're differentiating that, the half will go off, right? Because 2u and the half will go out, and minus v square will, the differentiation of a constant, we treated v as a constant here because you're partially differentiating with u, so that goes off. So therefore the first quantity will be u du, the second quantity will be minus v dv, same rule employed, and then the third quantity, this doesn't have any function of w at all, so therefore uh, uh, all these things are just treated as constants, and therefore the differentiation partially with respect to w will just be 0. So this is what we have. So now what we'll do is this is dz now for us. Okay, so let us write out the other terms. Dy we found out to be u sine w du plus v sine w dv plus uv cos w dw, and dx we found out to be u cos w du plus v cos w dv minus uv sine w dw. So now what you have to do is, we had this quantity, so d is s square, the differential, the line element was dx square plus dy square plus dz square. So now what we'll do is we'll take the square of all these quantities. So the square of all these quantities we'll have to take. So the square of all these quantities and remaining. So substitute that here, and you will get the your new line element that is required. So when you do that, what happens is, so just take the square of these quantities and substitute it here. You can check that. So when you check that, you will find that you get u square plus v square du square. So they'll all simplify because of some trigonometric relations. The cos and the cosines will go off using some trigonometric. So I'm not doing the calculations explicitly because this entails a more higher level graduate level course, so series. So therefore I'm not doing the calculations more explicitly. So this is what you would get. So now these factors, so this was our line element in the new coordinate system. So in place of h1 we have this quantity, and in the place of h2, here we have h2 next to dv square, we have this quantity. So in the place of h3 we have this quantity. So we are ready to write out our answers. So H1 is nothing but now in the place we have u square plus v square. H2, the scaling factor, is again u square plus v square. Right. So okay, so this is actually a square. So there is supposed to be a square here. There's supposed to be a square here. Supposed to be a square here. So the so h1 square is actually this quantity. Okay, so h1 square is actually this quantity. Therefore, h1 will actually be square root of this quantity. So square root of u square plus v square. So similarly, h2 will be square root of u square plus v square, and h3 will be h3 will be square root of this quantity u square v square, that is nothing but uv. So these is our answers. These are our answers. This is what we found. So we found them by comparing this result now that we got here, by comparing this result with this equation that we wrote. This equation that we wrote. I can again write it out here if you want to. So we just compared this ds square, the answer that we got, with this equation h1 square. So this is the new line element in the new coordinate system u, v, and w. So we just compared these equations and we got our results. So I'll write it out here. So that's the problem.